Yeah, so I'll repeat that. So when this thing grows, if it start growing like that, address and tomorrow another one and another one, hundreds of them, then we'll need to come here and change our code in 100 times, right? Which is
Mm.
horrible, right? So we wouldn't need to do something like that. That's where Kotlin shines. It'll give you it has a feature for you to copy across easily. So and also, if I make this private, then boom, problem again. Now what do? We can't, we want to copy across things with the address as well.
Mm.
But now we can't do it because we closed this. So instead of doing that, use Kotlin feature called copy. So only thing which is different here in this case is the name, the role, and the rest of them you're copying it. So even the private ones, the private attributes dot copy. Oh, sorry. Yeah. So what's the so this is so I have me, which is the one in the database, call copy on it with the new name, actually the name. So yeah, so I've copied the new name to the existing employee which is in the database using the copy function in data class, because an employee E is a data class, so I can call copy on it.
Mm.
Yeah. So now no breaking changes. I don't worry about the rest of them, even if it's private or I add another one, they will be get copied across. See, this is the beauty of having a copy function in Kotlin data classes. That's another
You
question.
copy.
Yeah.
So only then, so everything stays the same apart from that named argument you've copied, or
Yeah.
you're just copying the. I can't. I don't know what's getting copied. Sorry.
Just the name. Because according to our example, we said, we want to keep the address, salary, and everything the same, the roles
Oh.
as well, but we want to give another employee with the name differs, right?
Okay. Right. Right.
So
Right.
in that case, we don't want to create the class with all the single attributes repeated
Yeah.
again and again. We could just use
Just one thing is
yeah,
changed.
yeah, yeah, exactly. So I need to pass in the address as well. So let's say address is 123 ABC road or something. Yeah. So we are prototyping still. It's the prototyping design pattern is kind of used here because we are see. So Jason is also created with IT row, same
Yeah.
same address and everything, but the name is different, right? Yeah. So
Sorry,
uh,
Farouk, that address, is that a new attribute that got added, or is that one that was there already?
the address,
Yeah.
yeah, it's
Oh, right. I
new.
see what's
It's
happening.
new because in order to create an employee, you need to give in all these. Yeah.
Yeah, yeah, right.
But
Gotcha.
here we are creating another new employee, but our intention is to change the name only, and we want to copy
Only.
the rest of them. So you can just use
Right.
copy. Yeah.
Mm-hmm.
So copy and data classes, yeah, with the ability of having this copy in the data classes, you can achieve the prototyping design pattern.
Okay. What was it before when it was Java?
Clone, I think it's clone. Clone is there, but it has problems though.
Okay.
Yeah, but they have eliminated all those problems they had with somewhat called clone in Java with the copy method. Copy is, perfect. You can copy across the private fields as well, you know,
Right.
like we've just done. So
Okay. Yeah.
the highlight here is data class has copy in a situation like this. So if you want to create objects with similar which are similar but with slightly different attributes in this case,
Mm.
then it's the prototyping design pattern we are doing here with using the copy function in data class.
Yeah. You know that object. There was. I remember when I was doing the studying myself. There was 12 object
Hmm.
methods. There was 12 methods in the object class
Okay.
in Java.
Right. Yeah. And
Are these the object? Are these the methods that we get for free now in the data class?
yeah, I see what you mean. Yeah. Kind of. Yeah. Two string hash code equals.
Yeah.
the in Java is clone, yeah, and things like that. Yes, yeah. So all that, I mean, yeah, because I mean, you would need to override them every single time you create your class, and you want it
Okay.
implementations, right? But only when you want to change any of them. In like, I mean, the previous case, and I mean, we want to have a toString method overridden. Otherwise, it
Mhm.
didn't know how to print it. It was just printing the name of the reference of the object it
That's
was
right.
printing, right? So yeah, so they are the object methods. Yeah, it's on the objects.
Okay.
Object
It
itself.
just seemed a little bit similar, like when I saw the copy
Yeah,
and I was just thinking, oh, the toString, that was used as well. You get that for free. So I'm
correct.
thinking, do you
Yeah.
get the whole lot for free as well?
Yes, yes, yeah, correct. Hash code equals, they are the other two main ones.
Okay.
So an interview question will be, what is a data class? You will need to explain what is a data class, right? Yeah, to represent data in your system, right? Yeah, but you can elaborate a bit more from an example like this. And I mean, if you have an employee, you have you will create a data class with their attributes, right? The next question is, what are the what sort of free stuff you get with it, right? So
Okay.
the Spring implementations, hash code equals, they are implemented for you, so you don't need to implement. And the copy function you can use to, copy across things like this. That's it. That's a successful answer.
Okay.
Yeah, yeah. We ask these questions to anyone,
Okay. Yeah.
and that's how we measure how much Kotlin people know.
Okay. Right.
Sadly, I'm against those kind of questions as well because I mean, sometimes people don't remember everything, you know. Because
Right. Gotcha.
then how long would it take if I don't remember this? How long would it take for me to just go and have a quick look in Stack Overflow or Google it? You know,
Yeah.
next 5 minutes, right? I'll be ready with this is the stuff I can use this. So see, but then that's why I mean, it's better to see I mean where they're coming from and how much experience they have and what sort of projects they've worked on and all that. So,
Yeah.
but our interviews are more exam-based kind of questions. Can you tell me, or can you explain this or that, which is
Mhm.
crap. But sadly, that's what everyone does these days.
Okay. Yeah.
Yeah, but then again, just remember those. But yeah. So see, I mean, but again, yes and no from me. And I mean, if you have actually spent a bit more time with these things, you will know this by heart, saying, "Oh yes, see, like we've just seen," because if we're just doing it, you know, you know, if
Right. You
that
need
won't
contact.
yeah, exactly. Cool. All right. So that's the prototyping design pattern actually. Yeah.
Mhm.
Anything to add in? Anything to elaborate on?
No, that was pretty good actually,
Cool.
because I kind of understand where it's
Yeah.
coming from now and the free methods that you get
Mm-hmm.
with it.
Mm.
And it kind of makes sense now. I understand what I wouldn't have known what the copy done before,
Yeah. Yeah.
but when I've actually seen you use it and when you've explained it now, I can see what it actually does
Cool.
for the
Yeah.
actual properties. So yeah.
Yes. Yeah. That's what we want. That's the outcome should be from these exercises we're doing. That's why I've chosen design patterns. To see a problem and to write the solution in Kotlin. Yeah. So yeah, so just remember this as well, because the design pattern is also cool here. The prototyping. So think of it. I mean, if you want to create similar classes with different attributes, use the copy function if you're on Kotlin, or think of a design pattern, which is the prototyping. Which is what that does anyway. Yeah.
Similar objects with different, what did you call it?
Different
Yeah,
attributes.
different attributes. Okay.
Yeah. Yeah. Cool. Charith, happy with that?
Yeah,
Cool.
I'm cool.
Cool. Cheers. Right, so we can move on to the next one. Next one is also nice. And all right, actually, this is now we be in the structure. We're done with the creational pattern, guys.
Okay.
The creational patterns. Everyone
Mm.
uses, and which is out there.
Creating objects.
Yes, all about creating objects.
Mm.
Now, we'll come to this later, but I mean, let's do the structural because of it's the order we should follow. Structural, yes. So it's more like creational, but the structural is mainly talking about the relationship in between objects. right? So now we have created these objects. How are we going to keep them talking to each other, or defining their relationship and all that? That is also important, right? So if you don't tell or define or design a system which has a better relationship in between objects, the system will be considered messy.
Oh, when you said, sorry, Farouz,
Yeah.
for interjecting,
No,
when
no.
you said relationship, that
Hmm.
automatically rang something in my head, like separation of concerns or something like that.
Exactly. That is very true. Yes. So what is the separation of concern? The separation of concern is all about, keeping a good separation in between your layers, right? That means how do you group the objects into the right layers and stuff? And in order to do that, how do you make sure what are these objects? How do you class them as? I mean, what are their relationships? All that comes under
Oh,
that, right?
I was in the right ballpark then.
Yes, you're right. Yeah. So
Oh, nice.
yeah, well, IOC, the separation concerns. In other words, you can say IOC. That's inversion of control as well. So that means, how do you, when you design a system, right? We tend to keep layers. Like if you're building an Android app, yeah, I can
Yeah,
tell an example.
yeah,
You try to keep all your view classes in a view
that's
layer,
right.
right? All your domain classes, which are the business classes, the places where you would do calculations or figuring out what the system
Okay.
could do and all that. It's the domain layer, right? And then the data layer, of course, to represent all your data classes. What is the data you want? All the models, view models, not the view models. What I mean by the not the actual view model in Android. It's
Yeah,
the view classes, the models,
yeah,
the
yeah.
data.
The minute, yeah.
Yeah, data models, right? So that's
Mhm.
the architecture Google enforces us to follow as well. I can show you that as well. So that's good to check it out. Google Android architecture. It's something called unidirectional. Here. You see this UI layer? So
Mhm.
yeah, data layer. That's it. They are
Right.
layers. We will have all our Android views and everything will go here. So if you open this project, which uses this kind of architecture, you will
Yeah.
have a module for having classes which are similar, which are all views, yeah, and the same across all these layers, right? So when you do that, you're actually bringing in the separation of concern, right?
Mhm.
That you're separating the layers out because of the relationship of the classes you're grouping into, right? UI means, all the view classes. Yeah, that's the relationship, right? And the domain will, talk to the data layer to consume data, and will bring it back to give it to the UI layer. Yeah.
Mhm.
But if you don't have this separation of concern, and if you have the business objects staying in this view with the view class and all that, it's so difficult to analyze the system, right? It's so difficult to open this project and follow it through. It'll be
Right.
difficult. Which class does what and all that. I mean, there is no concern. I mean, separation of concern. Yeah.
Mm.
Yeah.
Sorry, I didn't mean to detour. It was just what came into my
No,
brain straight away.
no. It's good to detour. I mean, this is how we want to study, right? I mean,
Okay.
everything leads to everything. I mean, so it's good to check
Oh,
it out as we go.
okay, good.
Yeah, good that you said that word. I mean, separation of concern. Yes, and then using the dependency injection, you can then pass on the dependencies you want. I mean,
Right.
that's more for later. But I mean, yeah, Hilt, like I mean, if you use Hilt or Dagger, these are the dependency injection framework. But
Mhm.
you will then say the UI shouldn't need to worry about, I mean, what the actual domain layer he's talking to. We will provide the dependency through a dependency injection framework.
Mhm.
That's also a part of the separation of concern, keeping them in
Okay.
different layers. But I mean, using a dependency injection, you inject the dependencies you want rather than creating them, everywhere.
Mhm.
Yeah, right, cool. These are just the concepts, that we need to use in developing or building something. Right. Okay. So yeah. So the structural pattern is all about, I mean, how well we can define the relationship between the objects. Yeah. Yeah. As we saw, because if you want to have an architecture like this, how are we going to create the objects in these layers and define the relationship between them? You know, see, I want my domain layer objects to behave the same always. I don't want the domain layer object one day, suddenly convert himself as a data layer or something, a data layer object or something. So I want to clearly define my relationship in between when I group these in these layers, right? Yeah. So how do we make sure of that? I mean, this is when we're gonna make use of this structural design patterns help, and then the first one we can start looking at today is decorator. Yeah. Right. So the decorator pattern, yeah, as the structural pattern, which is to tell, how well we can um, extend the system or add some behavior to the existing system without messing up the relationship in between the objects, or without creating messy class hierarchies. Yeah, because when you have a class hierarchy, that is actually telling you the relationship in between the objects, right? Yeah. So I'm trying to word with the right wordings here, because I mean we said structural patterns all about how well we can define the relationship between objects. So the decorator helps you not to break it, so that you will end up with a messy hierarchy of classes. If you get into a messy hierarchy of classes, that is of course breaking the better relationship in between the objects, right? Isn't it?
Mhm.
Yeah. So, right. So let's see a problem and then see, how we can solve this with the decorator, right? Okay. So the first one in the structural is, oh, sorry. Decorator. Decorator. Yeah. Right. In order to do that, what is the thing we can build? Okay. Yeah. Let's see this. Let's see this. Right. Let's say, right. Let's say that we're building a shopping cart, right?
Yeah.
Yes. Let's say, yeah, we have a class called a shopping cart. Yeah. And then I'm going to have functions in the shopping cart to add items. Yeah, of course, we can add items, right?
Mhm.
But when I'm adding items, I want to add the items with, of course, the item ID or something.
Yeah.
Yeah.
The price.
Name. Yeah, or price. Yeah. Oh, okay. Oh no. Yeah. Yeah. We can have the price, but before that, I'm thinking the name of the item should be needed as well, isn't it?
Oh, okay.
Yeah.
Yeah.
The name of the item, so it should be name, string, and of course the price as well, right?
Mhm.
Int. Yeah. I always do this. No, I'm not really.
The val's not needed.
No. This is just a function, right? So these are the inputs, isn't it?
Yeah.
Yeah. But
That's
if you're creating a class, val can be used as well in the constructor if you want to keep them as fields. Yeah.
Right.
I always do that sometimes. Right. Okay. So we want to add an item, and we can search for items.
Search for items. Yeah.
Yeah. I'm just search item. If you want to search the items, we need the ID of the item to search whether the shopping cart has that item or not, right? So somebody will pass in the ID, right? So let's say this is our cart, right? This is actually the basket, right? It's a map of string because I want to store the ID. That's the problem.
Oh, yeah. The map.
Map of, sorry. Yeah, map of.
Okay. Oh, so they're the key value pairs again.
Yes, because I want to keep. I want my. What's wrong with this? I want my shopping basket to hold an ID and the name of the product. So when I'm
Right.
searching for it, I can just get the product name out of it and then query the database or something to look it up. Yeah. And also when I'm adding it, I can add it into this basket. So how would I add it? So I would add into this basket with telling this go with that name. Yeah. This is how I'll add it. So yeah, so I'll add the product which is coming in. We don't need the price because otherwise we will have to have a data class of what we're adding. But just think of it as the basket only holds the name and the ID, right? When somebody's adding that as he's buying that item, we will put that into the basket and say that this is the key for it. Yeah, ID, and that key is going to have the value of name because this is the map, right? Agree? Agree or not?
No.
Yeah. No. What's the problem? What's the question?
Do we still need that price in there? Is that what you're saying?
Yeah, I'm just adding something somebody's buying into this basket, right?
Okay.
But if you want to add a product, then create the data class.
Right. The basket, it's got the ID.
Yes.
Is that the index of the basket?
Kind of, yes. Then you have the price now, he said.
Okay.
Right. Okay. So then add the product into this, yeah, with IDs. Then I'm adding the product into this, yeah. Okay. So right, because of this is the key, not the index, because this is the map. Because I've created the mutable map, right, which is a map, which has IDs mapped with a product. So if I want to add an item, I'll need to tell what the item's ID is to put into this map.
Oh, I'm thinking of a list. Sorry.
Yeah, we can put it in the list as well. I'm just making it a bit more.
No. I mean, I'm thinking of it. That's why I was getting confused with the ID being an ID or
yeah.
When it starts at 0 and all that.
Correct. So yeah. Oh no, not the list. So if it's a list, you can just add it by the items. Sorry, index. Yeah. But
I
here,
understand it now.
Yes, we're putting that into the map with the key and the value.
Yeah. So the key goes into those brackets.
Yes, correct. Yeah, this is the way of adding a value by the key into a map.
Okay.
Yeah, simple as that, right? You can read it as in the basket. This is the key, and we're putting this value into that basket, for that key, right?
Yeah, I understand.
Cool. Now we've added that item. So if you want to search again, we want to search by the ID. So we want to return the item from the basket for that matching ID for the key. Oh, sorry. It needs to return the product. No? Yeah. Okay. This is a problem. See, we want the product, but it could be null. It's saying, you see this? We need the record this product, but it could be null because the map could return null if the key doesn't match. Yeah, in the map, in the basket already, or which is the map in this case, it could fail. It could throw a null, but we don't want to return any null products, right? So imagine, in order to do this, we can use this else operator, right?
Right.
There's an empty product or something. 0 price. This is an empty.
That's what I said to the man. Sorry for it. That's what I said to that guy the other day. I said, I should have said an Elvis operator. But when he said, if you don't, what techniques do we use when we don't want to return null? And I remember you saying an optional. Is this the same thing?
What was the question though? What is the technique?
What techniques do we use when we don't want to return null? Is this the same thing we're doing here?
We're now handling it, but it's Well, immediately when you ask, when I hear that word technique, you know, the optional is the pattern I use, you know, so that's why I said it could be the answer he was expecting, but
okay.
but your answer is also valid. I mean, you know, this is a technique as well, you know, to handle nulls, you know.
Yeah.
But you know, see, this is the problem though. I mean, we don't have a unified language, you know. I mean, in asking code related questions, you know. So people could think of something and ask you something else, you know. So, but that's why we need to go by a bit more technical words, you know. Technique in this case, it's the patterns or the frameworks, or you know.
It was kind of weird how he said it. He says, "What techniques do we use?" Because I said, "Oh, it's a nullable," and he said, "What if I don't want to return null? What techniques do we use if we do not want to return null?" Object.
Maybe he didn't understand, you know, the term you didn't use, because if you'd have said I could use an LBS operator to return an empty object if it's null, that's
maybe that's what it was. I should have.
Yes. But which is I mean, see, I mean, we don't worry about it. I mean, you know, what the guy knows or not, right? I mean, but we can definitely find out. I mean, what we want to study from this, or we want to learn from this, right?
Yeah. Sorry, mate. You can carry on.
No. I mean, ask these type of questions though, because all I want is to achieve from this is, I mean, we getting better on this, you know.
Yeah.
You know, yeah. So we can spend the whole time, I mean, having these type of questions answered. You know, that's what I want. Otherwise, we're not really achieving anything, I would say. You know.
Okay.
Yeah. Okay. Cool. Ask those up. Ask any questions though. You know. Right. We're not in a rush, right, to finish all these design patterns. What's the purpose, isn't it?
Yeah.
Yeah. Cool. All right, man. So don't be sorry about that. Okay. Cool. Right. All right. So we are searching for items in the basket, and then because of it's a map, it could return null. So we've put an LBS operator here. Why is it? Do you know why is it called an LBS operator? Where did this name come from?
Is it to do with the shape, because it resembles Elvis's hair or something?
You got that right. Yes, that's insane, isn't it?
Yeah. When I heard it, I was like, "Are you joking?"
Yeah, it's because of the shape, man. Bloody hell. Okay, anyway. Right. All right. So yeah, if it's null, we're going to return something empty. If not, you know, we'll go by it. I mean, whether it's the key matching it, right, in the basket, which is a map. Right. So we've done our shopping cart. This is ready to ship. Yeah. Right. So, you know, yeah, if somebody wants to use this, I mean, they will have to create this class, and you know, they can call these functions, you know, to do their stuff, right? Right. So imagine.
Sorry, Farouk, can you just do that? Can you just go over that return statement again?
Okay. Yeah. Sure. Definitely.
Yeah.
Right. Searching items, right? So we are searching for an item with the ID, because we want to search in this basket, right? The basket is a map of ID and products, right? ID is a string. So somebody will be passing in a key for us, you know, to search in the map, right? To do that, all right. So when we search, you know, what we want to do, we want to return the product, right? For that matching key coming in. Actually, I renamed this to be key. Then it's much easier to understand, right? We want to add stuff by the keys or something, no?
Okay.
Yeah. So this is the key. Yeah. So yeah, key is a string. Somebody can tell, you know, to get the product out. And the map, you know, we were looking for that item by the key. Yeah.
Right.
Same. If you want to put something in. I thought for some reason it's expired or something. No, it's not expired, right?
No.
Okay. Right. See, same when we put the value into the basket, we do the same syntax. You know, the basket key, that means where that is getting stored. This is the syntax to put in.
Okay, yeah, the product.
Yeah.
Going into the
Correct. Yeah. Yeah. So this is how you get the item too. Yeah.
Right.
Yeah. This is Kotlin syntax for you. You know. So yeah, don't try to compare both of them. But you know, I mean, anytime you want to add something, you say map where the key is and add it there. Yeah. If you want to get something, map the key that will return the item. But in this case, because of it's a map, it could be null.
Right.
Yeah. So that's why we
I was just remembering what the Elvis is.
Yeah.
If it is null, use on the left. If not, use on the right.
Correct. Otherwise, this would have been like, I mean, if, we should be using the if condition here now, so if this, you get this. No, actually first get this. Well, product is equal to this. And if P is equal now, then return this. Yeah, return this or else. Yeah, exactly. Else. Product. See how verbose is this?
Yeah, too much code.
Yeah. Whereas using the Elvis operator, you can
one line.
Yeah, exactly.
Yeah, I understand.
Yeah. Cool. Right. So now we are cool. Right. So now the requirement is changing. Right. This is what will happen. Right. Tomorrow, somebody will come and say, "Hey, look, when you're searching for items, can you also log what item we're searching? What because we log for marketing purposes, right, or analytics purposes, right? So I want to see how many what sort of keys we are searching the shopping basket, right? So then I'll need to do this, right? Just keep it a simple logging to this console. I'll need to say item searched for is or something, and then I'll print the key, no?
Yeah? Right.
So but here I'm adding a change to whatever the card we had. Yeah. So we're good. No, not really. Not really. Okay. This is the problem. So we want to log, but then the requirement is saying log in, but log it, but don't change the cart itself, so we want to keep the cart for any other purposes, so extend it and add the logging to it. So what we will do is, in that case, we will just, if you don't want to change our cart implementation, we will simply extend it, right? I'm doing this to show you how things will look a bit odd and dirty when you start messing with the class hierarchies. Yeah. So I'm making this open, and then I'm going to extend, because of we're creating an object we're defining an object for logging the logging card. Yeah. I will say card. Oh no. Card. And then make these open as well so that I can override. And then here I will override the search one. But when I am doing this, I will add my logging here. Yeah, then I'm not really changing the implementation of the card, the actual card, right? So I'm creating a new class by extending this card, and I'm adding the logging here, so that my actual implementation is not changed. Yeah. Yeah. Agree. So I've created a new object which is extending this.
Okay, right. Now I get it. Yeah, it's something to do with, is this polymorphism or something?
Yes, correct. Yeah, we're polymorphism. We're using polymorphism here. Yeah, because we are extending the parent. This is the parent, this is the child now. The child can override the search behavior in this case without changing the parent's search behavior by saying, okay, I'm going to do what you do, which is the search implementation here. But on top of that, I'm going to log myself. I mean, I'm going to log, what you're searching for. So we are extending the behavior here, right?
Right.
Yeah. And tomorrow, yeah, the same, next here, we can check, whether the name, yeah, whether the product's name is less than 10 characters or something, so if I want to add some validation here, I'll again create the class. Sorry. Validate cart. This is the behavior I'm creating. So it will be the cart itself. And then I'll now override the add item behavior. But here I'll call super to tell the parent to do what he's already doing. So I'm not changing that, right? So I'm leaving that. But in here we want to validate it. So I want to say it's product dot name length less than 10.
Show an error.
Yeah, why not? Yeah. Throw an error, illegal argument exception. Name has more characters, right? And also tell what that means. Then I'll need to do this, yeah. Get the product name here. And so this is how I can use the actual variable, yeah, in the log message in a string. Yeah, with a dollar symbol. Yeah. Yeah. So whatever the name is, I can print that name, and I'm saying has more characters, more than actually, more than 10 characters, right? That's what we are checking for. And in Kotlin, you can do this in a different way, which is much simpler way, a neater way as well, using a require function. The require takes the condition, so you just pass in the condition. Yeah.
Okay.
So the require means it has to be less than 10, and can put the message here. If that is done, if not, it'll throw the illegal argument exception anyway.
Right.
Yeah.
That's all the part of the require function.
Yeah, synthetic sugar. There you go. Rather than writing out if condition and all that, it'll do the same for us. So if you go into
just like the data class.
Yes. And no, it's a function. It's a function.
No, what I meant by that is we get stuff for free.
Yes. Yeah. So no, it's yeah. In Kotlin, you can use this synthetic sugar functions. So yeah, you see this? Otherwise, it's throwing the illegal argument. So it's part of the language. So it's already written for us. That's what I'm trying to say. This is already part of the language. So if you do that, you're repeating what the language is doing it for you.
Okay.
So simple as that. Yeah. So so we can just use the require check here, the function here. Yeah, so we're done with this, right? So validate car is also implemented. So the beauty is, so far what the good thing is, we're extending the default implementation without changing it, right? So we are extending the system with the additional behaviors. So here we're only just changing the logging behavior and keeping the adding items being, behaving the same. Yeah. So here we are validating. That means, we're just changing the adding items, but not touching the search items